So in our last lesson, we went over how to solve more complicated quadratic equations by factoring. So the good news is today, I think we're going to be covering something that's a little bit simpler to deal with. And our learning target is I can factor expressions by recognizing a difference of squares or the square of a binomial. So first, let's go over difference of squares. So a difference of squares is when we have a quadratic equation that when we factor it in factored form, it looks something like 0 is equal to x plus a times x minus a. So we're going to have the same number here, but in one case we're adding it, and in the other case we're subtracting it. So you might wonder, what's so unique about this case? And what's unique about it is if we FOIL out our factored forms, if we put it into standard form, we're going to get x squared minus a minus xa, plus xa minus a squared is equal to 0. And what you notice is we have a minus xa here and a plus xa here. So those are actually going to cancel out, and we'll get x squared minus a squared is equal to 0. So this is in factored form. And this is in standard form. So what we realize is the unique thing about a difference of squares is that in standard form it doesn't have a middle term. It doesn't have a first degree term in x because those terms cancel out. So now let's look at a couple examples. So if we have, say, x squared minus 81 is equal to 0, what we have to do is say, okay, so we don't have a middle term, so we know we have a difference of squares situation. So there are two ways we can solve this. We can solve it the traditional way, which is we can set it up like this, and we can say, okay, so our number here have to multiply to 81 and add to 0. So our possibilities could be negative 1 and 81. We could have negative 2, or 81 is not divisible by 2. 81 is divisible by 3. We could have negative 3 times 27, not divisible by 4, not divisible by 5, not divisible by 6, not divisible by 7, and then we get negative 9 times positive 9, and we notice immediately, bingo, negative 9 plus positive 9 is equal to 0. So that means that our answer is x plus 9 and x minus 9. And the solution to our equation would thus be x is equal to negative 9 or x is equal to positive 9. So that would be how we solve an equation using difference of squares. The other method would be, we have, say, x squared minus 25 is equal to 0, is we can start by adding 25 to each side, like we're solving a linear equation. We get x squared is equal to 25, and then what we can do is we can take the square root of each side. So what the square root does is reverse the process of squaring a number. So the square root of x squared will just be equal to x, and the square root of 25, here's where you have to be really, really careful, is plus or minus 5. And the reason that is why we have plus or minus here is because 5 squared is equal to 5 times 5, which is equal to 25. But also, negative 5 squared is equal to negative 5 times negative 5, which is equal to 25. So it is extremely easy to make this mistake and just write a positive 5 here. So remember, whenever you take the square root of a number, your possibilities are that you'll have plus or minus. And we will keep seeing this turn up for pretty much the whole rest of the unit. So those are your two methods for solving difference of squares problems. And the way that you recognize them is simply when you have a perfect square as this number, and when you're missing a middle term. So that is again how you solve difference of squares problems. So now we're going to look at square of a binomial. So a square of a binomial would be a situation in which we have x plus b times x plus b is equal to 0. So this is the case in which we only have one solution. So if we multiply this out, or FOIL it, you notice we'll get x squared plus bx plus bx plus b squared is equal to 0. And that means we have x squared plus 2bx plus b squared is equal to 0. So we know that we have the square of a binomial whenever we see a quadratic equation that looks like this. So it's a little bit like a difference of squares, except instead of canceling out, these terms add, and we get a 2bx term here. So the ways we can factor these, again, we have two options. Suppose we have x squared plus 10x plus 25 is equal to 0. We can notice, oh, hey, so 2b, if 2b is equal to 10, so if 2b is equal to 10, then b is equal to 5, and 5 squared is equal to 25. So since we have all of this information, that tells us, hey, the answer to this problem is x plus 5 times x plus 5 is equal to 0. So we can confirm this by FOILing these out. We get x squared plus 5x plus 5x is 10x plus 25, which confirms this. So our answer would be x is equal to negative 5. So in this case, since these expressions are the same, that means that we only have one solution. So the other way we could do this is we could just use the traditional method. So if we have, say, x squared plus 4x plus 4 is equal to 0, we can say, okay, what pairs of numbers multiply to 4? We could have 4 times 1, or we could have 2 times 2. And if we set this up, we know that the numbers also have to add to 4 in addition to multiplying to 4. So that means that this is the answer. And we can simplify this by writing it as just x plus 2 squared is equal to 0, which would put it in this form. And then we would get the answer of just x is equal to negative 2. So that is how you solve square of a binomial problems. So really, you can solve these problems using the traditional method of factoring, but it can just save some time and make things easier if you can recognize those two patterns and say, oh, I recognize that that's a difference of squares, or oh, I recognize that that's a square of a binomial, and it just makes these problems much easier to solve. So in our next lesson, we're going to shift gears a little bit, and we're going to go over a new method for solving quadratic equations that's called completing the square. So stay tuned for that.